W32, 32. How about that? We are making time. Okay, so I'm going to talk to you about the different questions here. Question 1 on worksheet 32 is use the series for e to the x to find a Taylor series. And there are two different ways. You can actually use those instructions, or you can use a different set of instructions. So I'm going to give you two different ways of accomplishing the same goal. I don't actually care how you do this. Two ways to do this. Okay? And your two options are, you can either know that e to the x plus e to the minus x over 2 is equal to hyperbolic cosine, which we lovingly call cosh, and e to the x minus e to the minus x over 2 is hyperbolic sine, which we call sinh. Okay, so you can know that. Knowing that, then that is the intended technique for doing this problem according to the author. Robinson wrote these. Okay, but the other way you can do it is you can know the following. If you know the hyperbolic sine has as its derivative, big shock, hyperbolic cosine. The reason it's not a shock is because you're actually already looking at the other side of the screen, right? So this isn't going to shock you. And the derivative of hyperbolic cosine is hyperbolic sine. And if you have that information, you also need to know that at 0, sine of 0 and sinh of 0 are both the same at 0. And cosh of 0 and cosine of 0 are both the same at 0. They're not the same anywhere else. It's just kind of a memory trick. You only get the first point for free. None of them match sine and cosine after that, okay? But you can use either path, and then you can put all the pieces together to come up with the answer. So pick your path. You can mix and match if it makes you feel better, but there you go. Okay, so advice on question 2. You're going to either try to do this generically enough that you get an expression with an n in it, or you can just do enough until you see a pattern. But here's what you do. This function, we're just going to call it capital S lowercase I. That's what we're going to call it. It's a function of x, and we integrate the following from 0 to x, which is sine of t over t dt. Okay, so what we're going to do is you're going to expand this sine of t, expand. All right, so what's it going to look like? You have to figure that out, but I'll just do the first two terms for you. Okay, and then you're going to divide by t. So this is going to turn into what? T squared over 6, and then all these other pieces downstream. Okay, so what you need to do is you either, I'm gonna let you do it yourself. You either put like 3 more terms or 4 more terms here and continue it until you understand the pattern. Or if you're more formal, you can write an expression with n's in it and then put some dots afterwards. Either way. So either or both. But somehow you have to figure out what the pattern is. And here's a hint. If you need to say an even number, it's 2n. And the very next odd number is 2n plus 1 is the odd number after that given even number. Okay, so that's your hint, and then you can use that so that for example, n is equal to 0 is going to turn into a 1, n is equal to 1 is going to turn into this term here. So that's my advice if you're going to go for the more formal expression here. Okay. So then what do we need to do? Well, it says degree 7. What does it mean to be degree 7? It does not mean, as I mentioned in the other video, you got to be careful about what is being requested. It does not mean 7 non-zero terms, which would be a lot. Degree 7 means literally that once you're done integrating, not here, but once you're done integrating, don't go past t to the 7th. So if there's a a 0 in front of t to the 7th, then you get that for free. But if it's a non-zero term, then that will be your last piece. Okay? So, so what you're going to do is you're going to have a certain number of pieces in your final answer. And that's after you integrate. So not just after you divide by t, but after you integrate. And then you're going to plug in the limits. Okay? I think the lower limit's just going to be 0 anyway. Like, I think when you plug in 0, it just disappears. So it's not as bad as it looks. Okay? So you're going to end up with however many pieces up to x to the 7th. And I think it's only going to be 3 or 4 terms. I forget how many. Then what you're going to do is plug in x equals 2. And what I'm going to ask you to do is like 4 to 5 digits after the decimal. So you'll get like something like that. You should be fine if you have that much accuracy. After that point, you can then, after you're done, then look it up on Wolfram or whatever. Okay? So I don't want you to avoid, like, I don't want you to think that you can't look it up, but just wait until after you've tried it yourself, and then if it's right, you'll feel reassured. So I'm all for that, double checking your work when you're done to make sure you got the right answer. Okay? All right. Okay, for question 3, this is really fun. I hope you enjoy it. I'm not going to give you too many clues, but here's the point. Figure out which series it is. And you can use that lookup table I showed you in the other video. Look up at that guy's website. Use that table. Figure out what series it is and figure out what x is being used. And that's for part A and part B both, like question 3A and B. I think there's 2 parts. Anyway, figure out which series and which x, and then that makes the whole thing super easy because then you just plug it right back into the function and you don't have to use the infinite addition. That's not the point. We're not trying to do that infinite addition thing. No. Okay, so then question 4 is your final question for this worksheet. And okay, you probably, if you need a hint, you literally, it says, you just do what it says, right? But people don't realize how easy this is. So you're really going to take sine of phi and replace it with phi. You're going to take cosine of phi and replace it with 1. And you're going to take cosine squared of phi and replace it with 1. Literally, then you finish the problem. It is really, really, really easy after that. The hardest part is you believing that that's as easy as it is. So just go ahead and do it now. And I will see you in class. Take care.